everyone. Welcome to episode 8 of the Artisan of Glimmith. We are playing this puzzle game. These are logic puzzles. We just finished up this complete section of the rose puzzles. Hope you guys enjoyed that series solving. That was fun. We're going to join into a new section here. This is the Delta section. So the rule here for Delta is that two regions touching, the symbols must be different shapes. So this is a sample puzzle. Now we have also the shape bank here. So we have to be either a 1x3 or a joint, a little, I don't know if you call it a V or a C. But anyways, the logic here is going to be, we can't do a 1x3 in here. So we have to put a corner piece in. And now we're told we cannot put corner pieces here. This cannot be a corner piece. This cannot be a corner piece. So these are together, but it's either going to extend one this way or one that way. I don't know which way. But we can say the same thing here. This is also not a corner piece. So it cannot extend along this direction. So it's going to have to go up in this way, that way. So that is now forced, which means this is forced, this is forced, this is forced, and that's the puzzle. Every one of these puzzles are solvable completely by logic. You do not have to guess. You don't have to try just different combinations, brute force it. That's not how it's meant. It's meant to be played using just pure logic. All right, so this looks almost identical, but this is, instead of being in the Delta, this is the Gemini. So we have the same shape bank. We have the 1x3 and the corner, the 2x2 corner. But the Gemini shape, if two regions are touching, they must be the same shape. So once again, we can't put a 1x3 in the middle. So that's forced. But now we know that this must be a corner shape. And so it's not going to go that way. It's going to have to go that way. Same things here. This is going to have to go that way. Now this cannot be a corner, so that's going to be a 1x3. This can't be 1x3, so that's going to be a corner, and that will be a corner. Again, all logic, 100% forced. Let's go around the bottom down this way. We either using a 1x4 or a 2x2, and we have some deltas, so they have to be different. So let's just start with what we could put here. Can we put a 1x4 in this corner? You would say, well, maybe we could do that. But then the question is, what shape goes here? And we're limited, right? We can't do a 1x4 because we have a border here, and we can't do a 2x2 because of the wall here. So this cannot be a 1x4. So we know this is a 2x2. Now, as soon as we know this is a 2x2, we already know this is a 2x2, but it is a 1x4. We just don't know if it's this way or that way. But this one, this is a little bit more telling because we can't do a 1x4 that way. It can't be a 2x2 either here or here. So this has to be part of a 1x4. It has to go there. What can go here? It has to be 1x4 as well. So both shapes forced on us. Now this makes this very easy. This is a 1x4. And this is a 1x. Oh, whoa, 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 whoa. Logic. What am I doing? Just putting shapes in. Bad fingers. What fingers? You just ran. All right. This has to be a 2x2. It has to be a 2x2. It can't be a 2x2 over here. It has to be a 2x2 over here. That is forced. This cannot be a 2x2, so it is a 1x4. This has to be a 1x4, which also does hold true that these are not the same. Down at the bottom, that is a 1x4, and we finish it off with a 2x2. Gotta watch out. Sometimes you know your body will trick you. Okay, looks very similar here. This is back to the Gemini rule, using the 1x3 and the 2x2. So we put that here. Once again, must be the same shape. So we could say, could that be the 2x2? It cannot. So the 2x2 will have to be here. Now this one, it could be like that, but it also could be something like that. So we can't judge anything based on that. But we can't come up in here and say this is not a 2x2. this is not a 2x2. And now we come and look here. Can this be a 1x3 this way? Oops. Can it be a 1x3 this way? Absolutely not. That is off limits. So that is a 2x2. This also must be a 2x2. Finish it off with 1x3s. All right. Switch back to the Delta puzzle. Oh, it combines them now. All right, now that we've mastered it, we can come through. So all three rules, we got the shape bank. These have to be a 1x1, a 2x2. Deltas have to be be different shape. Delta means change, different. Gemini, they have to be the same. So let's start with our 1x1s. We have to put 1x1s here and here. Delta must be different. So this is a 2x2. Gemini must be the same. So that's a 1x1. There we go. Now, can I put a 2x2 right here? I can't. So that has to also be a 1x1 because I can't finish this out. I have a delta, so this has to be a 2x2 on the other side. This is also a Gemini, so this has to be that way, and we finish it off just like that. All right. 1x2, 1x3. Those are our two shape options. We also have the delta. We also have the Gemini. So 1x2 could go down here, but then I'm stuck. So this is going to have to be a 1x3. Gemini says we need another 1x3. It can't be horizontal because that would break the delta rule. So the 1x3 will have to go this direction, which also forces that. This must be different. We can't leave this orphaned, so it's going to have to go that direction. And now this has to come out at least one, but if I do that, I have no way. This is going to be orphaned, so I have to take it all the way out. All right, we just keep moving forward. 1x3s and corner pieces. All right, so can I put a 1x3 in here? I cannot. So that has to be a corner piece. The delta means these can't be the same, so that has to go out. These do have to be the same, so that comes down. This can't be a 1x3, so it's going to be a corner. Can't get a 1x3 in there. This has to be a delta, so it's a 1x3. Nothing can fit in here except for a 1x3. This has to be the same, so also 1x3. This has to be different, so it's a corner. Over here, I can't get a 1x3 in here, so it's going to have to be a corner piece. We got a Gemini, so this will have to be a corner, and that will be a corner. Complete. Come into the courtyard. Our two shapes are a 1x1 and a 2x2. We have the delta rule and the Gemini rule both in place. Can't put a 2x2 in the corner, so that will be a 1x1. The delta says these must be different, so that's going to be a 2x2. I can't put a 2x2 here, so that is a 1x1. Let's move down. All right, here's some logic. If I said this is a 1x1, this says this is a delta. This can't be a 2x2. I guess the other way to put it is the other way around, saying this can't be a 2x2 under any circumstance. This is a 1x1. And as soon as we have this is a 1x1, this is a delta, this has to be the 2x2. Very simple. This is a 1x1, this is a 1x1 just by, in fact, we can just, all of these are kind of forced. This delta can't be a 1x1, so that is a 2x2. These are the same, so that's a 2x2. These are the same, that's a 2x2, 1x1. All right. We've got a U, we've got a 2x2, and we only have the Gemini rule. So here's the question. Could I put a U in here around this side? And the answer is not really. There's only one way a U could, I could put a U like this. I guess we could do a U like that. So we could do a square, we could do a square. So it seems like both options are available. I think the better answer is to start on the corners. Could I do a U like this or a U like this? And the answer is no, because either way creates a orphan. So this has to be a square. We have the same logic on this side. That creates an orphan, and this creates an orphan. So this also has to be a 2x2. So now we're down to the point, could I do squares? And you would say, well, it looks like you could do a square here and a square here, but you're left with orphans, so you cannot. So squares are not the answer. So it is going to be the U's to connect. All right, we're looking at this puzzle here. We have two shapes. We can either do a 1x2 or we can do a corner piece. The Gemini, they have to be the same next to each other. Delta, they have to be different. So they give us this little box. One thing that can fit in that box is a corner piece. The Delta says it's got to be different, but I don't know if it goes this direction or that direction. This has to be a corner piece. That's obvious. This could be a 1x2. This could be a 1x2. We don't know. Let's look at this. Could this be a 1x2? And the answer is no, because it leaves this orphan, because that box is there. Could it be a corner going this way? Nope, it's still the same problem. So this is the corner. This is a delta, so that has to go that direction. And now we are forced to complete that box in that manner. Now this one does have to go out, and it's not a corner because the delta tells us it's not. This has to go this direction. This has to go this direction. This has to be the same. That goes like that. And then the only way this is going to work, because we come down, got to make that a 2, and we make that a 2. All right, this puzzle, we have a 1x2, and we have a T tetronymo. We have the delta rule, where shapes next to each other have to be different, and we have the Gemini, where shapes have to be the same. Looking up here, could I make this a 2? The answer is no, because this has to be connected when it comes out. So this will be the T tetromino. Now, these have to be the same, but these have to be different. So this is the difference, which now means these will be the same, but it could be a couple different arrangements, so we're not going to guess on that. But these are a T of some kind. It could be, you know, like this. This one, it can't. Okay, so this one actually is pretty restricted. This is a T, but it can't go down with, so it has to be that direction. This has to be the T for the Gemini rule, which means this is a T, which is going to look like that. This one can't be a T. We got the delta rule, so put that in place. This can't be a T because that's the one place it can go. This has to be the same, so we'll put that in. This is a T as well, and there's no, I mean, the only original way that's going to work is that. So put that in there, put that in, we're done. Let's move up to this one here. We've got a shape bank of a corner and a 2x2. We've got the Gemini. It has to be the same across from each other. We got the delta. They have to be different across from each other. So this is interesting that this has a unique solve, because it seems very symmetrical. So it feels like we're going to have well, here's the thing. If I put a square anywhere, like if I put a square in here, I can't put a square anywhere else. Like this flat out breaks right now. So that's an interesting observation. If I put a square in the corner, that propagates all the way around. But then I've ran out of space. So if I put a square here, and I think this is the point. The square cannot go next to a Gemini, because as soon as it does, it propagates squares all over the place. Square can't go in the middle, because then it forces the whole border to be nothing but corners. So the only place we can put a square, and we can't put everything as corners because we do have to have some things different. It says there's, the delta tells us we're using both shapes. So the only place a square can go is here. And I think at this point, we are now just left with corner places everywhere. I mean, I think that's just how it goes. All right, our shape bank is a 1x2, And we have a cross pentamino, or X pentamino, I think is what they would refer to it as. The delta, it has to be different across from each other. Now, let's look in here. Can this be a cross? Absolutely not. But I don't know if it goes this direction or this direction. Can this be a cross? No. But again, I don't know which direction it goes. Now, the fact that these have to be different, I can't put a cross hardly anywhere. I can't put a cross on this side at all. Or an X. I keep calling it a cross. It's really an X. Pentamino is the official name. But it doesn't work. Like if this was the X, I can't go out either direction, and I can't go left or right here. So this is gonna have to be the 2. So this is the cross, the X, and I can't go up with it. So this is forced, and that's forced, just like that. This now can't be the X, so it's gonna have to go up. This has to come down, 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 this has to come over, this has to come over, this has to come over, this has to come up, this has to come up, this has to come up. Now I could do a cross here, so I'm gonna have to hold off. This has to come over, this has to come down, and now I have to use a cross because if I use any one of the 2s, it'll orphan the rest. So we'll put that in. So I like that one. That was fun. All right, so we got a 1x2. We got a circle. We'll call that O. Delta can't be the same. If across the line, Gemini, they must be the same. So these are where the pressure is. Let's look at the circle. Could this be part of a circle? So this could be a corner. So we could say this is a corner. It would go around like that. But what do I put here? That doesn't work. What we can see, a better way to place this is that if we're doing a circle, it's got to go around an empty space because there's nothing I can put in the center. So with this part over here, I can't put a circle on this side. Ergo, if I can't put a circle on this side, this can't be the circle either. These are both 1x2s. Let's go up to this section. These have to be different. One of these is a circle, one of these isn't. Can I put a circle on this side? If this were one lower, if this empty spot, I could put it right here, but it's not. So no matter where I put the circle, I'm gonna empty. So the circle is gonna have to go on this side. It can't go down here. So we can break, the puzzle break-in is that is the circle. We know we need 1x2. So 1x2, 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 1x2. I think we just keep layering this. I don't have, there's no, okay. Now we have to stop for a second. We know it's a bunch of 1x2s in here, but this can be a 1x2 like that. Yep, this is a 1x2, this is a 1x2, this is 1x2, 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 1x2. Yeah. And I hope you guys understand, like, what I'm not guessing there. These are, like, I probably didn't explain this really well. Yeah, I need to make sure I'm right here. What can go here? I can't put a circle there. So this has to be a 2 space. What goes here? It has to be a 2 space. So where's this connect? It has to go there. 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 Where's that connect? It has to go there. Where's this connect? Has to go there. Where's that connect? Has to go there. Where's this? Has to. Has to. Now that was a mistake there. Where does this one connect? Has to go there. Where's this connect? Has to. Has to. This is all 100% forced. None of this is me guessing. That has to go there. 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 Right? So anyways, I just want to make sure everybody understood I was not just pushing stuff in there, but I wasn't probably articulating my thought process as clearly as I should be. All right, we've got another window completed, but folks, we're not about window completion. We're about gilding out. We want to take it to the Gilded Age. We got more puzzles to solve. Okay, we got an L pentamino. We got an S pentamino, not pentamino, tetramino, like in Tetris. And we got Geminis. They have to be the same when they're across from each other. Now, this shape Whatever is here has to come out, come over, and go down. Now, it could continue down and make the L, or it could continue over and make the S. The problem is if we make the S, we block that cell. Can't be the S, so has to be the L. Now, this says this also has to be an L, so these two are together. It could go out this direction, or it could come down and over here. Now, this is going to, if I went this direction, that does not break that, because I can still go around this way, because this has to be as well. I don't know, but this says this also has to be a L, so we'll make that an L. Let's and this has to come out. It could come up, it could go S, it could go S, it could go L. If it goes L, that would be an L. That would break, because then this would be a dead space. Let's look at this. This has to come out, and it can't go up, so it has to go here and here, and it either goes here and makes an L, goes here and makes an S, which would make this an S, which would make this an S. And I don't think that's a problem. Is there a problem if this is an L? If this is an L, then this is an S. Then this is an S. Oh, that's a problem. Can this be an S? Wait. If this were an L, this is an S. But this would have to be an S. Well, let's put it this way. It doesn't matter whether this is an S or whether this is an S. This is an S. As soon as we know this is an S on both sides, this has to be the S. And this has to be. So now the question is this an S, or does the S come up? But as soon as we know that this is an S, then this has to be an S. And we know this is not the right S, because that creates the problem there. So the S has to come out this way, like that. That's forced. We know this is an L. We know this is an L. This is now completed. And this is the S, yeah. Trying to do these in somewhat of a logical order. All right, here's our shape bank. We've got a, I don't even know how you call this shape. It's kind of like a circular room. And then we've got a 2x3 that's offset. It's kind of like been switched over. This is going to be fun. Gemini, they're the same if they're next to each other. Delta, they are different if they're next to each other. Now, these shapes are very constrained. So like this right here takes 4... Like it's like a whole wall. Like it's got 2 walls that are, so it's like, it's going to be like a whole wall like this or a whole wall like that. It can't be a wall like this. That doesn't work. It can't go through. So at this side, it potentially could. But if it did, that gets messed up because this says it has to be the same thing. That's impossible. So we can guarantee that's not right. The fact that this says it's different. So here I see the solution. So let me put a different way. These 2 pieces fit inside each other. So I'm just going to draw them as is. I'm just going to draw them as, so that's one shape and then that's the other shape, right? So the 2 pieces go together like this, but then we've got to flip it, rotate it, contort it in some configuration to get it to match these rules. Now, what I want to point to is this side over here, because this right here is the clue that matters, this delta. The side on each side has to be different. Look at this shape. where is it that you have the shape divided in half where it's different on one side than the other? And the answer is right here. It's only between this part and this part. Now, the problem is I don't know which one's which, but I do know that that we're going to have part of it go this way and part of it go this way. And again, the center is all going to be either all blue or all yellow. I don't know which one. But let's switch it around the other direction, because this is saying whatever's on this side is on the other side. So, but this one's different. So we know these two are different. So let's this is going to be like a Boolean. If this is yellow, then this is yellow. Let me just keep get kind of a, there we go. That's a yellow. This also is yellow because it's different than that, but this one is, no, that's close. It's a blue, right? So going back to our shape, this shape has to be the long shape, right? Because there is no 3 long edge here. So it is this 3 long edge. This is where the shape changes. And if I take it all the way around to right here, that's the shape. This comes in like that. So that is this side complete. Now this is the same as this one, which means this comes in like that, and this will complete the puzzle like that. That's it. Hope that made sense. It's helpful to use colors or notes to mark which shape occupies a cell. Yeah, I don't like free form though. All right, so it's a 1x2 or a corner, and we have lots and lots of deltas. So we're told right up front, this is a 1x2. This one is, okay, so we're gonna make our color palettes very particular. This is blue. It's a 1x2. This is not a 1x2. This is a 1x2, not a 1x2, 1x2, not a 1x2, 1x2, not a 1x2. So we're going to use purple to mark the others. So where do we go? So up here, this has to be, and I don't know. Now I want to go back to, so that has to come up. This has to come up. I don't know if this connects or not. It could. All right, here's an interesting point. Can this be, we know that, can this be part of that 1x2? And the answer is no, because then it would connect to this. Wait, hold on. It could, but this one comes down. And then that's a corner. This has to be a corner. So let's just do that. This is something real helpful. It could be a corner. This could be a 1x2, and then that would push that direction. Or this could be a corner, and that's still a corner. Is this ever not a, can this? Yeah. Can this ever happen? Like, can that be a shape? And the answer is no, because that. So this does go that direction. That's good to know. All right, this has to be a corner, and it can't go up. So this has to come down. This can't be left open, so that's taken care of. This comes up, maybe it comes over, I don't know. This is a 1x2. This has to be a corner. So that comes down, this comes over. This has to connect to something that there we go. kind of got a little bit of roll there. All right, so this will be our last puzzle, more likely. We've got a W or an M pentomino, and we got a corner, and everything along this edge alternates. That's fun. All right, so let's see how we can approach this. So W's are very, like, I mean, they're much more difficult to fit into places. But we could, I'm just showing you like how you could fit them in. But like up here, there's no way to, I mean, the W would have to go like that. Like, can this be part of a W? If it is, it would be like that, right? So that is possible, I guess. Now, what about down here? If the W is like this, that's a problem. Because what goes in here? That doesn't work. This is the break-in. This has to come up. It can't go over here because that has to take that, and now I can't do it. So this is our first shape. This now is a W on the other side. So the W it can't go up that way, so it's going to have to go this way. On this side, it has to be a corner. It could be a corner up. It could be a corner down. We don't know. If this was a corner like that, then this would have to be a corner like that. And that's forcing all kinds of W's. And that actually kind of works. We can W the whole side over here. That'd be kind of interesting if this whole side is corners and this whole side is W's. That would be kind of interesting. Well, let's look at this. All right, if this were a corner, does that even work? Well, hold on. Let's do some math. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. I don't know how many shapes go in here, but I know when we add up the number of cells, it's 10. How do I do that when my only choices are 5 or 3? Well, I can do 2 5s. 5 plus 5 equals 10. But what combination of 3 can I get? I mean, 3 plus 3 plus 3, 9. 3 plus 5, 8. 3 plus 5 plus 3, 11. So it has to be 2 W pentominoes in here. And as soon as I do that, it has to be that. It has to be that, which means everything on the other side is a corner. So as soon as we do that, this has to come out. It could go here. It doesn't have to. It could go over here. This. If I go this way, that goes up. If I go this way, that goes over. Where's the pressure? Where's the pressure on this? These two are not connected. If these two are connected, then what is this one doing? It's in no man's land. Well, no. It could go this way. All right, if these are not connected, then this would have to go something like that. Again, I don't see the problem there. All right, let's do the math on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let me do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh boy. 16 is not divisible by 3. It's not a bunch of corners. So, 16, if I have one W, take that off. What does that do? That makes it 11. That's still not divisible by 3. Take another W off. That makes it 6. So that's telling me I get exactly 2 triangles and 3 W or 2 W's. So I've got, so here's, I only get 2 triangles. I only get 2 triangles. That's the key. And all of the edges on here have to be triangles. These are all triangles. So we can just come up here right here and say right away, those are triangles. So this W, this W, and there we go. Solve a heart-shaped puzzle. All right, folks, we are going to stop right there. Went a little bit over. Thank you so much for the support. Leave a comment what you think about the game, what you thought about these puzzles, any solutions that you thought were particularly beautiful. Some of these I think are some beautiful logic. I hope to read those, comment on that. Leave a like if you're enjoying this. Subscribe if you haven't. And whatever you do, I hope to see you next time. Take care, everyone. Bye-bye.